Hello again. Let's continue looking at other ways to prove equations in type theory. So let's say that we want to prove this as an example, that for any three numbers n, m, and k, we could either add them up this way around, where we first add n and m and then finally k, or we could first add m and k and then add n, and this should give the same result. So it doesn't matter how we bracket these things. Right. Okay, how do we prove this? Well, we could try to just give REFL, being very optimistic, but it's not obvious that these two things are the same, right? So what we have to do is we have to again ask ourselves, why is it stuck? And if you remember, we defined plus by looking at the first argument. So this is stuck because we don't know what the n is yet, right? And this is stuck because we don't know what this thing is, but maybe if we know what n is, we might know what this thing is. Similarly, this is stuck because we don't know what the n is. This is stuck because we don't know what the m is, but that doesn't really matter if this is stuck overall. So it looks like looking at n is the right thing to do, so let's do that. Okay, let's see what we have to do now. Now this is much easier to prove, right? So we've seen that n is 0, which means that this reduces to m plus k, and this reduces to m plus k as well. So that's provable by REFL. And what about this one? Well, this time we could again use a cong to peel off these sucks, but let me show you another way to do it, which is to use the rewrite keyword. So we say rewrite, and then we say something we want to rewrite by. And what would it make sense to rewrite by this time? Well, inside here we have another instance of the thing we're proving, right? It's not so clear because Agda has been kind enough not to write out the brackets when it's nested the right way, but it has written them out this way. So if we do a recursive call, so let me delete the rewrite for now. So if I do a recursive call on n, m, k, then I see that that's going to fix the thing inside the suck, so I can rewrite by that. And I reload the file, so I write rewrite, and then the proof that I want to rewrite by, and I see what happened. See that Agda has done that rewriting for me, so now the goal has been transformed, and now it's easy to give this. This is just REFL, right? Okay, and note in particular that I can rewrite by a recursive call of the same thing. Same rules about doing recursive calls applies, no matter if you put them on the right or if you put them here on the left when you rewrite. Okay, so what actually happened? Let's look at a slightly contrived example to see if you can see what Agda is doing when you rewrite. So let's say that we have some p which depends on a, which is a set, and we have a function from a to a, and we have some elements of a like this. And let's say that I have an equation that says that the left hand side is equal to the right hand side. This is the thing I want to rewrite along. And in the end, my goal is to produce something in p of left hand side, f of left hand side, x. So I've introduced the left hand side directly, the left hand side inside something else, and something irrelevant, right? So that's what I would like to produce, which I can see if I look at my goal. That's what I have to do. But what I have is something where instead of these left-hand sides, I have a right-hand side here. So this one is already right, but here I don't have the left-hand side that I want. But I have a proof that these two things are equal, so I should be able to do this. Right? So if I now rewrite along by this proof, and I reload the file, let's see what happened. So before I had to produce something of this type, right? But now, if I look at my goal, we see that Agda has replaced all the left-hand sides with the right-hand sides in my goal. And similarly in everything in my context, right? So I used to have a left-hand side here, but now that has turned into a right-hand side, which means that I can now use the thing I have to prove the goal I wanted. So the thing I wanted was called P. Right? So what rewrite is doing is it's replacing all the occurrences of the left-hand side with the right hand side in the goal and the context. And you can also do this multiple times on one line. So let's look at this example where we're trying to prove that n plus m is the same as m plus n. So this is commutativity of plus, right? And this time it's not easy to see why is it stuck, because this one is stuck because of n and this one is stuck because of n, right? So yes, let's just pick one. We're going to pick m. And there is a right choice, and I think I hope I remember the right one. If not, you have to go back and fix it. Okay, so here we have to show that n plus 0 equals n. Well, we proved this before, I think. That was this plus identity, right? So that's what that works. And this is the interesting case, almost like always. So now we need that n plus suc m is suc of this. So we can't just do a cong here, right? But we proved something about n plus suc m before. This plus suc. So if I apply this to n and m, that takes me somewhere, right? This matches, but here it doesn't quite match yet. But if I rewrite by that, that should get me part of the way there. Let me do that. Okay, so now we can do a cong of suc if we want, or we can do another rewrite, because what's left to do is to change this n plus m into an m plus n. That's a recursive call. So I do a vertical bar, and then the other thing I want to rewrite by as well. And now let's see what my goal is. Now I've gone all the way to a goal which is actually trivially true. Right. So you can have multiple rewrites in one line if you want. And what have we learned? Well, you can use rewrite to change the type of the goal. And this is, when it works, often easier than fiddling around with cong, etc., because you don't have to specify where you want to rewrite. You just do it everywhere in your goal. On the other hand, it doesn't always work, so sometimes you have to revert to using cong and things like this directly. And as an aside, there's nothing magical about this rewrite. You can do the same thing with width, and width in turn is also nothing magical. You can always desugar this into something that's not using these features. That could be something fun for you to think about if you want.